All right. So what we're going to look at today is atomic number and atomic mass. Okay. So all of these numbers that you have on your periodic tables, we have in a number that is above and a number which is below. So the atomic number on your periodic table, if I was to draw an element here, and let's call it hydrogen, okay? Hydrogen above has this number here. It has the number 1. This is its atomic number. That is the atomic number for hydrogen. So, our first question asks, if all atoms are built up of protons, neutrons, and electrons, what we've just looked at, describe what makes the elements so different from one another. So what is going to change as we go from, say, hydrogen to helium? So if we look at helium, I draw the box here. Helium, the difference is it has the atomic number of 2. The thing for us to know is that the atomic number is equal to the number of protons. So what is the main difference between hydrogen and helium then? They have a different number of protons. Okay, different number of protons. So what makes the elements so different from one another? It is the number of protons. And where are protons found? Great, in the nucleus. So the number of protons found in the nucleus. Okay. Now, we established that atoms are generally equal. And if they're equal, that means that they have to have the same number of protons and electrons. So what could we say here? The number of protons found in the nucleus and the number of electrons. Okay, so I'll write electrons in blue. And what's happened here? And the number of electrons. Now, out of these two, we said when we were talking about the structure of atoms that perhaps the number of electrons can change. If the number of protons changes, it changes the element altogether. So out of these two, come test time and when you're explaining things to me, the one I really want you to talk about is protons. The reason there is if we change the number of protons, it changes the element. Something that we will discover shortly is that if we change the number of electrons, it just changes the overall charge. Okay. So, each element has an atomic number, and as we said, this represents the number of protons. So each element's atomic number represents the number of protons. Hydrogen has an atomic number of 1, and this means that all hydrogen atoms have 1 proton. Something that I'm going to make very, very clear here. The number of protons in an element can never change. What will happen if it changes? It will change the element. Very good. So, if an atom had 2 protons, would it still be hydrogen? No. What element would it be? Helium. So, if an atom had 2 protons, would it still be hydrogen? The answer is no. Why? Because it has changed to be a helium atom. So, I've kind of answered part C here. What atom would it be? It is going to be helium. And out of good practice for us, next to helium in brackets, what is the scientific symbol, chemical symbol? Capital H, little e. Okay. So, the number of protons in an atom is called its atomic number. I'm not sure how much clearer we can make it other than underlining it and putting in all caps for you. I'm not going to highlight that simply because I hope it's abundantly clear to you. Now, I would like us all to have a go at explaining why atoms are electrically neutral. So why, or where do we get electrical charge in atoms? Let's start really simply. Where do we get our 2 forms of electrical charge? Electrons give us what kind of charge? Okay, electrons provide negative charge. And what's our other components? Protons. Protons provide positive charge. Very good. Now, why are all atoms going to be neutral? Well, we already know that neutrons have no charge. So what is this going to mean for us overall? To be electrically neutral, to have no charge, we're going to need the same number of protons and electrons.
Don't they cancel each other out though?
Exactly right, and that is why they become electrically neutral. They cancel one another out. So our final point here, the most important point for us, why are they electrically neutral? Atoms have the same number of protons and electrons. So this fourth dot point that I've put in here, that's the real answer. The 3 dot points there, we're just setting the scene to really explain that one. So that now that we have an understanding about atomic number, we're now going to talk about atomic mass, okay, and the mass number. So a minute ago, we drew 2 boxes like this, and we said that this first one was hydrogen and this second one was helium. And then up the top, what did these numbers 1 and 2 represent? The atomic number, okay? Now, if you look on your periodic table, okay, you will see that we now have a number below, okay? And you'll see that for hydrogen, the number is 1, okay? And what is the number for helium? Let's check. The number below helium is 4. So, this number here, and I'll use my green highlighter now, this is what we call the mass number. Okay? Now, how we determine this one? We know that protons and neutrons have about the same mass, okay, about 1. And electrons have a relative mass of 0, okay? This means that the mass of an atom is determined by how many protons and neutrons we have. So, if we look at helium right now, okay, and we zoom in a little bit here, helium. How many protons are in helium? If we look at the atomic number, it is the same as the number of protons. So how many protons do we have in helium? The atomic number. So the atomic number is the one up the top. How many protons do we have? 2. Okay. If I then look at the atomic mass, okay? The atomic mass is this thing that I've written in green. So atomic mass. It is equal, okay, to the number of protons, okay, plus neutrons. So if I have 2 protons, how many neutrons do I need to equal 4? 2. So this number above, okay, the element 2, is how many protons there are. The number below is how many protons and neutrons there are. So if we have a look at a different example, lithium, okay, we can see here the atomic number for lithium is 3. I'll get to questions in just a second, okay? The atomic number is this one at the top, 3, okay? It is the same as the number of protons, which is 3. If we move down, we can also see the mass number of lithium, and the mass number of lithium is 7. The mass number of lithium, 7, is equal to, firstly, the number of protons plus the number of neutrons. Now, if we know that the number of protons is 3, and we know that the mass is 7, how do we go from 3 to 7? What can we add? We can add 4. And so this tells us that the number of neutrons in this instance is going to be 4. Another way that we can figure this one out is if we have a look, we can go that the number of neutrons, okay, is equal to the mass number, which is green, subtract the number of protons. And what this ends up giving us is 4. Okay? We have 4 neutrons. Now I had a few questions.
How come chlorine's the only decimal?
How come chlorine is the only decimal? In actual fact, the periodic tables that we've given you are actually rounded up. Okay? So these mass numbers that we give you are averages. Okay? And we'll explain that when we talk about isotopes, but for instance, we've said hydrogen is 1. Hydrogen is actually 1.008. We've told you chlorine is 35.5. It's actually 35.453. Okay? So all of these masses that we've given you are just easier versions for you to remember. Okay? Yes, yes, yes. I'm just going to work my way down the line. Yeah.
Why are we working out the number of electrons if, isn't it 0, so do they not matter?
The mass of electrons is 0, you're right. However, as we said just up here, we said that the number of electrons and, here we go, the number of electrons and protons is the same. So that overall the charge is 0. What we're talking about now, however, is we're talking about the weight. And when we talk about the weight, we're talking about how heavy this particular atom is. Okay, does that make sense? Okay, yeah. Absolutely. You will always have a periodic table in the test. Will it be the same one that you have right now in front of you? No, we give you a blank one when you come in. A blank periodic table. So the same way that when you got it on the first lesson, exactly right. Great. So, are you allowed to draw on it? Yes, because it's laminated. Okay. So, what we're going to do now, okay, we're going to have a practice at identifying the atomic number, the atomic mass, the number of neutrons, protons, and electrons. So we're going to work through oxygen together and zinc together, and then I'm going to let you go and finish the rest.
How are we supposed to know what the protons and neutrons are?
Let's work through it right now, okay? So, when we talk about O, if you look on your periodic table, it has the name for the symbol O. And we know that O is oxygen. Now, we know a few key things. Let's break it back down again. Number 1, up the top, this number here is what? We call this number 8 the atomic number. So the atomic number for this example is 8. The second number that we have is in green down the bottom here. And this number here represents the mass number. Now, when we have the mass number, this is 16 for oxygen. So when we're talking, we are now looking at the number of protons. Okay? And which number, the mass number or the atomic number, tells us the number of protons? The atomic number. So I'm actually going to highlight number of protons here in the same color that I've highlighted atomic number, because they are always going to be the same. What happens if our atomic number changes? It changes the entire element. So for these ones, it's really important that they remain the same, and you'll see that we have 8 for both. Now, the same thing is going to be true for all electrons. When we talk about electrons in an atom, they are the same as the number of protons. So how many electrons do we have in oxygen? 8. Lastly, the one that we need to figure out together is the number of neutrons. And so the number of neutrons we calculate in the following way. We say that the number of neutrons is equal to the mass minus the atomic number. So, in other words, the number of neutrons is equal to the bottom number, subtract the top number. And in this case, that is going to be equal to 16 minus 8. And so the number of neutrons is 8. Okay,
What is the atomic number?
let's do one.
Is it negative?
Zinc. Okay.
Is it a negative?
No, it will never be negative. Okay. So let's have a look at zinc.
It's 0, isn't it?
Let's have a look at zinc right now. The symbol for zinc, if you can find number 30 on your periodic table, is capital Z, lowercase n. The atomic number for zinc, okay, is the same as the number of protons, is the same as the number of electrons. And we can see that in this example, it is equal to 30. The mass number is this number down the bottom here. And we can see that in this case, the mass number is equal to 16. The final thing that we need to figure out is how many neutrons there are. So what I'll do is I'll go back up the top here to my formula. Number of neutrons. Oh, apologies, don't know what's happened there. Scroll back up. Sorry, it's really not liking me all of a sudden. There we go. If we get rid of that, what is the mass of zinc? Someone please. 16. Oh, I see what's happened here.
So is that
Okay.
negative sign?
Is it just 0?
Yeah. No, you know what's happened here, everyone, is that we've accidentally had zinc's mass come out wrong. So when we look for zinc, where do we find zinc? Okay? Right here. And you'll see that the mass here is being incorrectly printed. So what we're going to do right now, I'm sorry, I can see why some of you are getting a little bit confused. What we're going to do is we're going to erase that. I'll get my white pen out here. The mass for zinc. Can you go, what have we given you on your periodic tables? Because have we given you 16 on yours?
65.
On your periodic table, does it say 65?
Yeah.
Yep, so what we're going to do now is we'll fix this one up. That should be 65. Apologies. Okay. And so what we're looking at, if the atomic number is 30, the mass number is 65, we're going to end up with a mass of 65. Subtract the atomic number of 30, which gives us the number of neutrons in this case being 35. So, apologies for the confusion with that second example. I do understand now. Okay. What you're going to do, can I get you to go through and again practice the rest of these ones for me, please?